Hello everyone. In this video, we are going to see about AWS Elastic Load Balancing. Before we get started, let me introduce about myself. Myself Mahendran, and I am an AWS Solution Architect Associate and an active AWS Community Builder. I have acquired AWS Builder Quest Bronze and a Cloud Quest for Practitioner as well. And you can follow me on LinkedIn. This is the agenda which we are going to see today. First, what is elastic load balancing and load balancer benefits, how elastic load balancing works, features of load balancing, and pricing, and a demo as well. Now, let's see what is elastic load balancing. Elastic load balancing is automatically it will distribute the incoming traffic across the multiple targets. So that in the targets, in that means like EC2 instance, containers, and IP addresses, and that is in one or more availability zones. And it also monitors the health of the registered targets. So the registered target means the EC2 instance, and it also routes traffic only to the healthy target. If it is going to be unhealthy, the traffic will not be diverted to the unhealthy targets. And also, elastic load balancing scales our load balancer capacity automatically in response to change in the incoming traffic. Now, let's see the load balancer benefits. Load balancer, it will distribute the workloads across multiple compute resources such as virtual servers. And using the load balancer, we can increase the availability and the fault tolerance of our application. This is actually an important one. So that it serves the load balancer is having a great benefit. And also we can add and remove the compute resources from our load balancer as we need change. For example, currently if your environment is very small and if you are having two instance in the load balancer, but if your environment is going to be big, then we can easily add two more instances as well in the target group without disrupting the overall flow of our request. We can easily add and remove the compute resources, and we can configure health check which will monitor the health of our EC2 so that the load balancer will send the request only to the healthy ones. And also, we can easily offload the work of encryption and decryption to our load balancer so that our EC2 can focus on our main work. Now, let's see how elastic load balancing works. So, here a load balancer will accept the incoming traffic from client. It will route the request to its registered targets. Here, we have mentioned this as EC2 instances in one or more availability zone. So I can have this EC2 as in US East A, or this EC2 instance I have maybe running in US East 2B. And what happens is the load balancer will monitor the health of its registered target. So this elastic load balancer will monitor the health of these two EC2 instance health, and it ensures that it routes the traffic only to the healthy target. For example, if this EC2 instance is having some issue or the status check has not been passed, then only the traffic will be flowing to this specific instance alone. So that will be monitoring. The health check will be monitored by the elastic load balancing. When the load balancer detects an unhealthy target, what it will be doing is it will stop the routing traffic to the target, and it then resumes only when the load balancing detects that okay, that particular instance is in healthy status. Then only the traffic will be going into the unhealthy instances once it became healthy again. And also we can configure our load balancer to accept incoming traffic by specifying one or more listeners. So actually here what has been my listener is a kind of a process that checks for the connection request. So how it is being configured is we will be having a protocol and a port number for connections from the client to the load balancer. So we can configure with a protocol and port number for a connection from the load balancer to the target. So in the same manner, we can configure in the from the load balancers listener as well. Now let's see the features of elastic load balancing. Before we see that, in the elastic load balancing supports, there are four types of load balancers. One is application load balancer, and the second one is network load balancer, and the third is the gateway load balancer, and the fourth one is a classic load balancer. So the classic load balancer is actually retired on August 2022. So currently, the three load balancers are only in place. And the features, according to the features of elastic load balancing, so the first thing, as I said, how the elastic load balancing work, it will easily detect the unhealthy EC2 instance. And the second one is like it will easily spread the EC2 instance across healthy channels only, so that we can have the application availability at the most 100 percentage. And also centralize the management of SSL certificates. So we can easily integrate the AWS certificate manager, so that we can easily offload, or we can easily have that encryption and decryption part in the load balancer itself. And the main thing is like it is used to support for both IPv4 and IPv6 as well. Now let's see the pricing. With their load balancer, we pay only for what you use. Like for example, an EC2 instance has been registered as a target, right? So those two EC2 instances will be paying as a price, like how much hours it is been running. Accordingly, we need to pay for it. Now let's see a demo on this. We will be creating a load balancer, and followed by that we will be having a two EC2 instance, and also we'll be manually stopping the server, and we'll see how the traffic is getting diverted only to the healthy instance, and also once it has been healthy again, how the traffic is getting diverted from one machine to the another instance. So as we said, we are going to create two EC2 instance and load balancer attached to it. So before that, we'll create two EC2 instance. So I'm just going in here, EC2. So I'm just launching an instance from here. You can give a name for the server. So I'm just giving a name called web server 1. And I'm just giving the default OS image, that is Amazon Linux 2. The instance type as well t2.micro. So as we are doing a demo, right? So I'm just using the free tier eligible. And also you can create a key pair as well. So I'm going to allow HTTP traffic and also HTTPS. And the remaining thing I'm going to keep it as default. And as I said, this is I'm going to configure as a web server. So I am going to add the user data. So what is user data? We can have some script. It can be given at the launch of the EC2 instance. So I already have the script in place. So I'm just going to paste in here. So here you can see a shell script, so which will log in as a sudo, and after that it will update the existing packages, and it will install httpd package. And after that I'm going to pass this entry to the index.html file, which it says welcome to server 1, so that I can easily identify from which server we are getting the request. And also once this is being done, I'm just starting the service and also enabling it, so that even if a reboot happens, it will be enabling it. So I'm just keeping the remaining settings as a default. Now I'm going to launch the instance. So here you can see by clicking on view all instance, or here also you can see it. Now it is in pending. And also here you can see the availability zone as US issue 1A. Now let's create another instance in the meantime. In the same way, you can click on launch instance. I am giving web server 2. And the same OS and the instance type I'm going to give the same, and I'm just using the same key pair which is being used, and I'm just using this existing security group which was created for the previous server. And here I'm just going to give the same script but just a small modification in that. Here I'm going to give it as welcome to server 2. So I'm just launching it. So we can check here whether both the instances are in running state or not. So the first server it is in running. Let's wait for some 1 or 2 minutes to come into running state. So once both the instances are in running and also the status check passed, we can go ahead and create the target group and the load balancer. So here you can see both the instances are in initialization state. So let's wait for some time, like 1 or 2 minutes, so that we get 2/2 status check passed. Here you can see for one of the instance, the status check has been passed. Let's wait for some 1 or 2 minutes so that the web server 2 also will comes 2/2 check passed. Now you can see both the servers, the instance state is in running and also the status check also passed for both the instance. Now we are good to create the target group, and after that we can create the load balancer. Now to create the target group, you need to go in here, target groups, and we need to create a target group. So you can click on create target group. And here you can see a lot of options to create the target type. So if you select application load balancer, if there is an existing application load balancer, you can use that. But as we are going from the scratch, right? So we can use the target type as instance, and you need to give a target group name. I'm just giving my target group, and I'm just giving all the things as default. Why? Because I'm just having only one VPC, that is a default VPC, and the protocol is 80. And the health check, I'm going to have it as a HTTP and slash, and I'm going to next. So here it will be asking for what are all the instances it need to be added in this particular target group. So here it will be showing like what are all the available instances. So I want to add both the instances need to be added in the target group. So I'm just selecting both the instances and I just clicking on include as pending below. So once you clicked on here, it will be coming in here. So it will be at the start, the health status will be in pending. So I am clicking on create target group. So our target group has been successfully created. So here you can see both the instances has been added to the target group. But here, if you see the health status details, it is saying like target group is not configured to receive traffic from the load balancer. Why? Because we have created the target group. We haven't attached this target group to the load balancer. So that is why it says it is not configured to receive traffic. And so to do that, to receive traffic, we need to create the load balancer. So I'm just going to load balancer. So click on create load balancer. So here, as I said, load balancers, they have three types of there, like based on the different scenarios. So if you are going to use network data like TCP or UDP things, you can use network load balancer. And if you are going to use a fleet of third-party virtual appliances, so you can use gateway load balancer. But for now, we are going to create an application load balancer where we are having an HTTP and HTTPS traffic. So I'm just clicking on create. So here I'm just giving my load balancer as a name, and I'm just going to be to see as a demo. I'm just going to use a scheme internet facing. So if you are going to use an internet, that is also you can use it. And here, as I said, load balancer is having great benefit. Like we can use it for IPv4 and IPv6 address. So we are going to use it only for IPv4 for now. And here it is showing like for the different availability zones, we can configure the load balancer as well, so that if one availability zone goes unavailable, we can easily get the traffic from other availability zone. So I'm just clicking on all the availability zone you can also select, but my EC2 instances are available only on US East one way. So I'm just selecting US East one way alone. And the security group, I am just going to use the existing security group, which was created during the EC2 instance. And I'm going to remove the existing one, which is a default. And here you can see the listener, as I said, right, we can have a port number and the target group. So here I am going to select the target group, which I have created before, right, which is having two EC2 instances attached to it. So our target group has been selected. And this is the summary of which what are the things which we have selected for this load balancer. And I'm going to create the load balancer. And also here it says two subnets. The load balancer, the main thing is like we need to have two availability zones to be configured. So I'm selecting US East 1B. So I'm clicking on create load balancer. So it has been created the load balancer, but so I want to show you some two to three things. So here you can see the listener has been configured and this has been mapped to the target group, right? So if I go to target group, before it was showing like the traffic was not receiving to this target group and it is not been configured with any of the load balancer. But now we have configured the load balancer, and now if you see, it will take some like 1 to 3 minutes to update the status of the health status. Now here you can see the target registration is in progress and the health status also it is in initial. So from initial it will change to healthy. So once it becomes healthy, we will try to access the DNS and we'll see what is the output it is coming. And if you remember, we have given a user data script, right? A shell script which has been passed to the instance for both of the things, right? So it will be showing like welcome to server one and welcome to server two when I do a refresh of the particular URL. Let's wait for some couple of the minutes so that once the health status become healthy, we can try to access the endpoint. So it will take some time to become healthy. Now you can see both the target, like both the EC2 instance or the are having the healthy status. Now to access the load balancer endpoint, right? So how to get that endpoint? So to easily we can get it. So from the load balancer, if you click on description, you can see the DNS. As I said, as I have configured this load balancer as the internet facing, we can easily use the specific DNS name and we can accessible from the internet. So I'm just copying this DNS name and I'm going to access it from here. So there you go. We have configured in the shell script as welcome to server one, right? So which I try to access it for first it is showing like welcome to server one. If I do refresh here, you can see that traffic is getting diverted to the second instance. If I again refresh, it will so even it is getting diverted. You can see it, right? Welcome to server one and two. Automatically, it is getting diverted based upon the load accordingly. See. So now we have configured, we have tested our elastic load balancer and it is working fine. And we are seeing the index.html page of web server 1 and the web server 2, like both the things. If we do refresh, the elb is equally dividing the incoming traffic to both the servers in a round robin fashion. So to do further testing, what we will do is I'm just going to stop the first EC2 instance. So I'm just going to EC2 management console and going to instance. So the first server, right? I'm just going to stop it by going to instance state and stop. Let's wait for some couple of minutes. So once this has been stopped, we will see like what all the things are happening. It is in stopping. Now you can see the server has been stopped. Now I'm just going to target group and see what is the health status of this specific instance. Here it is not yet updated. Why? Because here now you can see it, right. The web server one and the health status was unused, and the health status details it is showing the target is in the stop reset. So the one thing is like we can easily find out like what is why the health status shows unused, or any other status. If it shows, it will display like what happened to that particular health status. It will display the exact details. So here it says the target is in the stopped state, and now if I'm going to access this particular DNS, only the traffic will be going to the server 2 alone. So even though if I do refresh multiple times, it is the traffic is only going to the server 2 alone, and from there only I'm getting the I'm getting the response. See, only I'm getting the response called welcome to server 2 alone. Even if I copy and do it in another tab, here you can see only from welcome to server 2. So only the ELB is rendering the HTML page from the second instances alone. So this is how the load balancer easily detects the unhealthy instance, and without any a kind of impact or a downtime for the application, it will easily divert the traffic to the healthy instance alone. So this is how the elastic load balancing works. Now, as we have completed the demo, I'm just going to delete the resources which we have created. So first I'm going to delete the load balancer. Here you can see yes, delete the load balancer. So once the load balancer has been deleted, why? Because deletion is also one of the key criteria, like one of the best practices. If the resources are not used, deletion is also one of the key criteria that needs to be followed. And then I'm going to delete the target group. Yes, delete. Once the target group has been deleted, I am going to delete the instance as well. and instance state terminate. So here you can see it will be shutting down and then it will get terminated. So from this demo, we have created two EC2 instances with a bash script, so which have installed the Apache servers, and we have created a sample HTML page and we have published it. And after that, we have created a load balancer and a target group. And we have added both EC2 instance in the load balancer target group. And after that, we have tested the elastic load balancer by refreshing. And also we have done a kind of a simulation like where we have shut down the one of the EC2 instance and we have seen how the traffic is getting diverted to the healthy instances alone. Thanks for watching this video.